Greetings, folks. Joseph Kursky here with you, examining data now that has been generated in the field via a smartphone app. With just a smartphone, you can collect data and map it and analyze it. Exciting times to be in spatial technology for sure. Let's examine first a map in Arcgis Online, our web-based GIS platform that was created from data generated in the field. This map is entitled Motion X GPS Track. Hike to 34 North, 117 West is by me, J.J. Kursky. It's going to look similar to this right here. The following steps that you'll use on this map should start to seem familiar, folks. They follow a standard procedure that you've used in different places in this module and represents a workflow that you can follow in your future use of spatial technology. What do I mean by that? I mean opening the map, changing the legend, changing the symbology, opening the table, zooming and panning, clicking on things and investigating, adding data, changing the base map, all that kind of stuff. This should start to be familiar to you because you're using it time and time again. All right, let's get started. Let's click on the Contents tab to the left of the map to view the layers. You'll note that the map contains 4 layers: map notes, track points, track lines, and a satellite image base map. Some layers expand when you click on their names in the Contents tab. The track, for example, expands into points and lines. This is because certain field data collection apps collect different types of spatial data simultaneously. In this case, the app that was used in the field collected point data and line data. Each is useful. Second, open the table for the point and line layers as shown here. Note that the line layer only contains 1 feature, while the point layer contains 581 features. The fields in the point layer include the elevation in meters and the date/time. The point layer is symbolized by elevation, and if you take a quick look at the legend, you'll see that the red colors indicate higher elevation and yellows indicate lower elevation. The points are like little breadcrumbs, little virtual breadcrumbs that drop on the ground as I hike along. Third, zoom out a bit to see the entire hike, noting the type of vegetation and terrain traversed, location of the beginning and end of the hike, and which sections of the hike followed a trail and which did not. Yes, I did get off trail. I'm a geographer, hey! And the high and low points along the hike. Change the base map to a street's base map to answer the following question. At the west end of which street did the author park on to begin the hike? Change the base map back to imagery. Click on the 2 push pins to see the photos taken at those locations. These push pins are map notes, which you have used in this module in the past. Zoom out further until you can determine the region of the world in which this hike was taken. It's the chaparral biome of Southern California, USA. Very fire-prone, as you probably know, as in many parts of Australia. Zoom into the hike, use the ellipses for track 002 and then zoom to as shown here. That's the fastest way to zoom to any feature in ArcGIS Online. Fourth, use the measure tool to measure the distance between each of the points that appear along the lines. What's the average distance between each point for a certain section of the hike? These steps from 1 to 4 above, as I've just described, that include opening the data table, measuring, changing the scale, and accessing the symbology, again, are standard procedures that you can use on any map and set of layers in ArcGIS Online. All right, folks, let's dig deeper, examining the app and the types of field data. In this case, the data were collected with a smartphone app called Motion X GPS. Motion X GPS is one of a series of apps. Others include Gaia GPS, Polaris GPS, and others that collect points and lines in the field. They all emulate a GPS receiver on your smartphone, including displaying locations in a number of different coordinate systems, routing, distances, and directions. As you saw on the map, 2 formats of data are typically collected in the field: point data and line data. Points can be track points, which can be thought of as, again, digital breadcrumbs that are dropped as you move along the landscape at a specified distance or time, such as every 2 meters or every 1 second. Points can also be waypoints that you drop on purpose at locations that you specify, where you measure water quality along a shore, or at a tree or a light pole, or at a street corner where you're measuring noise. Fitness apps such as Runkeeper, Strava, or MapMyRun often output point and line data that can also be mapped. One of the common formats for these files is a GPX file, which stands for GPS Exchange Format, a type of XML file for exchanging GPS data between programs and for sharing GPS data among many users. So, when examining smartphone field apps for use in education, seek ones that allow for output in a variety of formats, including GPX. Even though these apps often contain their own mapping interface, what is more useful for educational use, I believe, is the ability to bring field-collected data into Arcgis Online, a spatial technology tool that can actually have you being able to examine, analyze, investigate, and so on. If the app itself does not output into an exportable format, sometimes the website for the app includes that capability, such as runkeeper.com. Now, be critical of the data's spatial accuracy. In keeping with our module theme of being critical of the data, before leaving this data set, zoom to the eastern side of the collected data near the white circular water tank. Even though the person collecting the data, me, walked on the trail in this area going up and down the ridge, note the offset from the trail for one of the tracks. By examining the date and timestamp on the data, you can determine whether the offset occurred on my way up the slope, climbing from east to west, or the way down, descending from west to east. Measure the offset of this section of track from the trail as shown on the satellite image. The points could have been compromised for any number of reasons. In terms of positional accuracy, the field worker, me, could have inadvertently shielded part of the phone with his hand while gingerly picking his way along the trail while collecting the track, but the cell phone reception might have been fallen off. Dense vegetation or the high ridge to the west could have prevented the phone from sensing as many cell phone towers, Wi-Fi hotspots, and GPS satellites as it had done along the ridgetop. Or the app might have not been recording accurately here. Other reasons could exist too. This compromising of positions happens when using GPS receivers as well, and it's something that you and your students need to be continually examining and questioning. It happens most often near ridges and canyons, such as the case here, but also in city centers with high-rise buildings, and also from within a building, or when the field data collector first leaves the building and goes outside. Discuss with students the different accuracy requirements depending on your project. For mapping trees on campus, being a few meters off, no worries, forget about it, no worries. It might not be a problem, but it would be a problem for objects placed more closely together, such as mapping headstones in a cemetery or pieces of litter along a street. Discuss the even finer accuracy requirements for such things as mapping natural gas lines or fiber optic cables. Also, be critical of attribute data quality. Thus, spatial data quality is important. The quality of attributes, the information that you collect in the field, is also important. Your database will consider SPRUCE and SPRUSE, spruce versus spruce, to be two different types of trees. They're spelled differently. It doesn't know that they're the same thing, actually. Some data entry errors can be solved by the use of pull-down menus for field data collection. Minimize the amount of free text entry that has to be done in the field under various conditions. Associated with the attribute data quality is ensuring consistent devices and clarity on methods used, for example, to measure the height of a tree. Also associated with attribute data quality is paying close attention to the units you are using in the field. If some students are collecting tree girth in centimeters and the others in millimeters, and others in feet and inches, that could lead to potential misinterpretation of results, right, folks? Similar results could occur if one student collected pedestrian counts along a street for 1 minute and another student for 5 minutes. Now that you've had experience examining field data in an interactive web map, you're ready for the next step. In this next unit, you're going to build your own web map with the same type of data that was used for the chaparral hike that you examined here. Thanks.